Okay, hi everyone. I'm here today to talk about reusability in the context of React components. And I want to leave you with some tips and patterns, making sharing components more enjoyable. So to introduce myself, I'm Frischmann from Germany, and I'm a front-end engineer at DM Drogeriemarkt, which is the biggest drugstore in Europe. And to the left, you can see a picture of me giving my first ever big conference talk just 1 year ago at ReactiveConf in Bratislava, which is why I'm super glad and happy that I have the opportunity to be here again. Thank you. And now, speaking about reusability, I think the first thing we should probably look at is how do we reuse components in general? And it turns out that in theory, this is as simple as just reusing a plain JavaScript function. Because in fact, we can describe a component as just a function that takes some so-called props and then returns some markup that is then rendered to the DOM. And now that's basically all we need to reuse this component in like everywhere, just like we do with this button example. But obviously, I wouldn't be here if it was always like that simple. And it turns out that in reality, it's rarely as simple like this, because our code base is growing and changing, and it's steadily evolving with new features and new use cases. And we need to make our components adapt to those changes. And eventually, we also have to satisfy like more and more use cases, which might result in growing complexity. And at some point, the button component we showed before might end up something like this. You have a lot of props, a lot of conditions, and a lot of logic and stuff inside there just to make it reusable. And actually, it's kind of intended that you can't really see anything, because I just want to give you a feel how complex a simple component like a button can get. And I think we can agree that the button should probably not be that simple. So what would you do if I would now tell you, please implement some new feature in this button, right? You would probably not even try to understand it because you're afraid of breaking something, but you would probably just go, copy-paste the code, and eventually we would end up with something like this. But it's not going to be any better, because now we have to deal with a lot of duplication, and if something changes, like in the core of the button, you would have to change it in many different places. And it turns out that this is also especially true for open source components, because they need to fit for literally thousands of use cases. And as a result, I've seen very many open source components that were super complex with like 100 props or something like that. And this might be the reason for the following. So even though we have like thousands of components on NPM, I can barely see them used in any project. And this is pretty sad, because the concept of a component is pretty cool. You have a small encapsulated module that you should be able to reuse everywhere. But somehow this doesn't work in most cases. But I think that doesn't have to be like this. And I want to invite you today on my journey we took at DM, exploring some issues we found when reusing components, and I want to present some possible solutions for them. And to do that, we will look at 2 different types of components, which are presentational and logical components. And for those of you who don't know, there's a concept in React which is kind of about splitting presentational components and logical components, where the presentational components are all about styling and markup, so they are like dumb stateless components. And on the other hand, we have those logical components that are all concerned with business logic and behavior. And we are doing this because, as you will later see, both of those type of components have completely different problems and solutions in terms of reusability. So to start with, I'd like to explore how we can reuse presentation. And first of all, I got some component examples, so you better understand what we're talking about. And so basically, everything you would include in a style guide can be considered a presentational component. So for example, if you have some typographic components, or if you have a set of buttons with different variations, and as we can see, we can also have different pseudo-classes like hover, active, and disabled, so it doesn't need to be like a static component. And then we can also go on and compose smaller presentational components into bigger ones, like for example, this card component, which itself uses an image, and heading, and a text component. And now that we know what we're talking about, we can explore like the goal with presentational components in terms of reusability by asking ourselves what makes a presentational component reusable. And we might say that it's the ability to adapt to as many different use cases as possible, just like we've seen with this button before. And the way we can achieve this is by making our component customizable. So now we have to think about what can actually be customized for presentational components. And if we look at this definition for the presentational components again, we can see that it turns out to be the styling and this markup part. So our first goal is to accomplish style customization. And I want to do this by looking at this previous button example again, which was something like this. And as you can see, it's pretty simple. It renders to this gray button there. But now let's say we want to have another button, like, for example, this one, which is blue and has some rounded corners. OK, so the first thing you might want to do is just add some new props there, and some new style properties, and you're done. You got your button. But you can, as you can think of like this growing and growing more complex because you have more use cases, the common case is to kind of extend the styling. And as we can see here, we're composing like these base styles with some custom style that is passed by the user. And this allows us to add any other style to the button if we need to. And OK, now it might be reasonable for single element components like this buttons that just renders one node element. But what if we look at this card component again, which has multiple elements, and now let's say we want to customize every single element of this component. And we would have to use many different style props just to achieve that. And it even gets worse if we want to do responsive styling, because we might end up passing values for every breakpoint, for every property, for every element we got in there. And now just imagine you got maybe like 5 properties. You already have like over 50 different props. And just imagine the mess you can create with this. But still, in reality, I've seen many different APIs that kind of work like this, from a more explicit one like this one, to something that's like this, where we rely on some naming convention to apply those responsive styles, to something like this, which basically allows you to pass in anything. So you kind of can do a lot of stuff, but you also don't have any convention at all. And as you can imagine, any of those APIs can get super big and pretty fast again. And eventually, at some point, we might just give up. And especially developers who are not too familiar with those, the implementation details and whatever, they might just go back to the one single solution we have to override styles confidently, which is using this important flag again. Yeah, but obviously, that's probably not what I want you to do right now. So, as you can say, we also suffered from those issues at the a lot, and we tried all kinds of different APIs just to find out that it, again, just doesn't really feel like any better until we discovered another approach. Yeah. So what if, instead of hard coding all those properties, we would leverage the power of a design system in combination with theming? And we've already seen in Mark's talk that we can do pretty cool stuff with design system. So I found this library called Style System, and I want to show you a quick example of using this library together with another library which is called System Components. And it basically uses this styled system library together with styled components, which is a CSS and JS library. But you can probably use it with like any other styling library if you want to. So it's pretty general, and you can adapt it to a lot of solutions. So the idea of styled system is that you define your design system as a theme object. And it also provides some clever shortcuts, like, for example, those breakpoint values. They actually resolve to something more complex like this. And it also adds those pixels to the sizes and spaces and whatever. But you could also just pass the full value if you don't want to rely on this magic at all. And if we look at how we can implement this button before again, we just need to call the system function with a set of style groups, which we want to be customizable, where each of those groups represents a set of style properties, like, for example, this space stands for the margin and padding, the font size just stands for the font size, and this color goes for those color values. And if we look at so that's fine right now, but if you look at those values that are passed to the button, they look a bit strange, right? Because you would probably not want your font size to be 4 pixels. And now if we look at this theme again, it turns out that the number actually refers to the index in our array. So this 2 actually stands for the 8 pixels. The 3 stands for the 16 pixels, the 4 for the 24, and so on. And if we look at those color values there, it turns out that those are not hard-coded values, which you might think in the first place, but they also refer to the color values in the theme. So for now that's fine, but what about responsive styling again? So it turns out that it can be done by passing an array instead of a single value, where again the index represents the same index in this breakpoints array. So this 4 actually relates to the smallest breakpoint, and so on. And yeah, I think that's a pretty cool idea here, because we are implementing this styling customization API with the exact same props all the time, and they are all centered around this single design system object, which we're passing down from above. So yeah, now that we know how to provide great style customization, let's look at the next big part of presentational components, which you probably might already guessed is rendering customization, because next to the styling, we got this structure, which is basically the way something is rendered. And I want to showcase like the main issue using this card example again. So let's say it's implemented something like this, where you got this card component, it renders a div with some special card props to make it look like this card, and then it just renders all those nested components. But now let's say at some point we want to reuse this card component, but instead of using this heading 4, we want to use a heading 2, because we want to make this title bigger or something like that. But still, we also need to have this heading 4 at some other places. So you need a way to customize the way this heading is rendered. And the first thing you might do is extending the API again, like passing a heading prop to customize a rendered element, and you're fine. But as you can imagine, the problem is if we do this over and over again, we will end up with something super complex again. Now, the solution I'm proposing for this is probably not actually a solution, but more like avoiding the problem in the first place. And we can achieve that with embracing composition over configuration. So instead of configuring everything via props, we just don't render those nested components in the card in the first place. But we compose those components together separately, so the card component only remains rendering this div with the special props and then just renders the children. And if we now want to use this heading 2 component instead of the heading 4, all we have to do is change the single line of code without touching the card at all, and we're done. OK, and to finish off this presentational part, I just want to give you a quick reminder. So even if I'm showing you some solutions, I still want you to always challenge what you're all actually doing, because those solutions, they may work in a lot of places, and they especially helped us at DM to get our stuff done. But this doesn't mean it's like the solution for everything, but it can rather just help you if your components grow too complex. And I can only recommend to start as simple as stupid as possible, and then later add abstraction as soon as you need it. All right, but now let's look into reusing logic. So again, I want to give you some examples, and some common examples for logical components would be something like toggling a menu, handling some drag and drop stuff, but also doing some state management, some API calls, and something like this. And I brought a simple visual example, which we're using to explore later. And yeah, consider this component, which takes a GitHub username, then calls the GitHub API, fetches a list of repositories, and sorts them all by stars. And then, in the rendering part, we go on and render this information as some like visual cards. And if you look at the simplified implementation, it might look something like this. We got some state, then we have this fetch method that actually does this GitHub call and updates the state, including a loading indicator. And then if we look at the rendering part, depending on this loading indicator, we are either rendering this loading component or actually rendering those repository cards. And using this component is as simple as just rendering it to any element with the owner passed as a property. But there's one major issue with those kind of logical components. And let's say we want to customize, for example, this loading component. So instead of having this cool bubble loading thing, we want to go on and use this like old school spinner stuff like that for some reason. Or another example would be, what if you want to use this component on mobile, but it turns out that this card component doesn't really fit there. So we rather want to go and use some kind of list item component. So now if we look at those issues again, it turns out that it's not really a problem with reusing this logical part of the component, but again, it's a problem with the presentation. And the reason for this is, even if we split those logical and presentational components, we still have to render something at some point to make use of this logic. And usually you would do this by rendering some presentational components within the render function of your logical component. And just as I'm saying this right now, if you think about it, it might sound kind of stupid, doesn't it? Because again, you now tightly couple the presentation with the logic, which is not what we kind of wanted to do in the first place by splitting them. But somehow this turned out to be the common way to implement logical components. But instead, I would say the presentation shouldn't be a concern of those logical components at all. So yeah, luckily there's like a solution to this, which is pretty simple, but it emerged just some months ago. I think it's not that old, actually, and it's called Headless Components. So a headless component is a logical component that encapsulates some logic, of course, like this fetch the GitHub repos. But as the name concludes, it doesn't actually render any UI. So you could say it's a user interface component without a user interface. But as we already learned, we need to render something at some point to make use of this logic, or we just wouldn't have to write it at all. And that's actually the clever part of those headless components, because instead of internally handling all this rendering in the render function, it utilizes the render props pattern by calling a render function, giving all the rendering power to the user again. And I want to explore how this concept applies by using this GitHub example we had from before. So if you look at this code again now, we can see that the logic part is still the exact same, because that's the concern of the logical component, and we want to reuse this one. But if we look at the rendering part, we can see that the rendering got way smaller, because actually we don't have to render those cards anymore. And in fact, we just call this children prop with all this relevant data we got. And you don't have to use this children prop in general. It's just like more the common way in the community, but you could call any prop that a user presses in. But obviously, this also comes at a cost, because now we can't just use this component as we did before and we're done, but we have to do some extra work. We have to pass a function as children, what receives all this relevant data we passed in and returns the actual markup we want to be rendered. And if you look at this markup, it turns out that it's the exact same markup we had in the logical component before, but just split apart and put in another location. So now you might ask, OK, but how does this help me? I mean, all you did is like putting this to another location. But if we go back to the problems we had before, like rendering this different loading component, all we now have to do to achieve that is by switching out this loading with a spinner component, and we're done. And this also applies to this like mobile view example, where you want to use this repository list instead of the repository card. And you can just switch the component, and you're done. And the important thing here is that we don't have to touch the logical component at all. And this makes it easy to have coexisting like variations of this logical component working together nicely without any issues. But actually, the cool thing about headless components is that since they don't render anything, they're most often also platform agnostic, which means with just some small changes, we can now also use this component in React Native and basically in every like rendering target for React. If you're using something like React primitives, which Mark showed before, you would probably not even have to change anything at all. OK, and now to finish off, I'd like to go one step further and show you how my team at DM uses those headless components to implement something we called CRUD components. So consider the following UI. You have to know we're building an online shop because we're a drugstore, and we need the customer's addresses at some point to ship the packages with the products. And this is just a design prototype, which it might look like. And as you can see, we can have different addresses. We can edit, we can remove them, and we can also add a new address if we want to. And then in the back end, we got a REST API that looks something like this, and that's it. And usually, now the front-end developers would go and use this REST API directly, which means they would have to implement like the error handling, setting up the fetching with all these different configurations. But they would also have to do the state management, like updating this addresses array, because if we click on this remove button, you actually want to remove this list item as well as soon as the request is successful. Now, the problem is that we have many different teams that implement specific front ends, but they all need to use those addresses APIs. But they don't know anything about this specific domain. And if we do it just like this, they would have to go to the REST API and do all this stuff repeatedly. What's even worse, if the API changes, all of those teams would have to go there and change their components again. And we thought about how to improve that and came up with this idea we call CRUD components. So basically, they're headless components and are pretty similar to like what Apollo is for GraphQL, but for REST APIs. And the way you use it is super simple. You just import the relevant API component you need, pass all the required props to it, and then render any UI given this specific API interface. And our interface might look something like this, where you got this array of addresses, you got 3 methods to add, update, and remove this address, and that's it. And the cool thing is, the front-end developers don't have to think about this actual API call anymore, because this address API component does like everything for them. And it even handles the state. So if you call this addAddress function, and it successfully does the call, it automatically updates this addresses array, which re-renders the component. So we kind of ensure that our front end and the back end are always in sync. And yeah, now before I finish off, I'd got one more little thing I quickly want to mention, because it's driving people crazy since Friday evening, and you guessed it, it's a React Hooks API. And if you're not familiar, just check it out, it's pretty cool. But if you're familiar with it, you might now ask yourself, okay, so doesn't this replace this whole idea of headless components? Like, isn't what you're telling us right now is already outdated as of now? Yeah, and I'm pretty happy to tell you yes and no, because it's true that you don't have to write this component with these render props anymore, but still you have to think about this logic and presentation in separation. But the cool thing is with hooks, this address API could now look as simple as something like this, where you just call this use address API within your just basic function component, and that's it. It will work. OK, so just let me sum it up very quickly. We learned that reusing the presentation is all about customization, and we learned that improving the customization can be achieved by leveraging the ideas of design systems and theming, as well as embracing composition over configuration. And then we found that reusing logic can be achieved by really strictly splitting the logic and the presentation using, for example, headless components, and probably in the future using React hooks. And I hope this can help you to write more reusable components in the future. And yeah, that's it. Thank you for having me.
Thank you, Robin, for sharing a nice presentation on sharing components.
Thank you.
We have some popular questions waiting for you. Should we take the top one? At what point should one decide on a new component is needed, instead of altering an already created one with new props?
Yeah, that's a pretty tricky question, because many people have many different opinions on this. But I can tell you what I usually do when I encounter something like this, which is I basically don't create components when I'm like prototyping something at all. I just write down a single huge tree of components, elements like diffs and whatever. And I do this up to the point where I'm like so exhausted and bored of this, like scrolling through everything, that I can start extracting components. And I think it's pretty useful if you wait as long as you can to do that, because that way you kind of make sure that you're not stripping out the wrong abstractions in the first place, because that's way more effort to get right after it than by just like copying, pasting stuff until you're confident enough, like, OK, this looks like a really repeating pattern. Yeah.
OK, thank you. When changing a theme, for example, adding breakpoint, how do you find all usages arrays to update?
Yeah, actually, that's a good question. I'm happy to. I never like got into this problem. I can imagine that it's quite difficult, actually, but maybe a solution would be to add this new breakpoint at the end of your breakpoints array, so you don't, at least you don't break your application at first. But you still would have to go to all the places and add like a new value for this breakpoint. So basically, that's yeah, a big drawback of this idea. I never thought about this, actually.
Asking good questions. Thank you. Thank you for your speech and your answers.
Thank you for having me.